Dear students, today we are discussing about quality control test for tablets. So as we know that quality control means it's a process by which products are tested and measured to ensure that they meet a specific standard. Okay, so while we are preparing or manufacturing tablets, there is a need to test the or to measure the specifications that whether these tablets has met or not. So, so what are the need for quality control test? So that means to ensure safety, potency, efficacy, and patient compliance of a tablet, to check whether the tablet satisfies certain standards, and also to check the quality parameters are within the acceptable limit. So quality control means nothing but it's a procedure or it's a steps that are taken during the manufacturing of a product to ensure that it meets the requirements, specific requirements or the standard requirements that it should be needed. Okay. Then there are two types of quality control test, official test and unofficial test. So the official test includes weight variation, drug content, disintegration and dissolution. Unofficial test includes thickness, hardness, friability and organoleptic characters. So coming to the first classification, that is unofficial test. So now in unofficial test, organoleptic characters comes. So in organoleptic characters, we are testing the color, odor, and taste. So coming to the color, so the tablets, we know that it's available in a lot of different colors. So the main purpose of coloring the tablets means the first thing is the identification and consumer acceptance. So while at the time of coloring, the thing that should keep in mind that is that the color on the product should be in uniform. Okay, so non-uniformity of the colors on the surface of the tablet, that defect is known as mottling. Okay, so that is the colors will be separated on the tablet surface, or some patches of colors will be produced on the tablet. So, so we should be, and it should be ensured that the color on the surface of the tablets is uniform. Next is order. So order is also we are sometimes different tablets will be having different smell. So the smell is mainly again for the consumer acceptance, and also if the active ingredient present in the tablet sometimes will be having some sort of order. So in order to mask that order also, we will be adding some flavoring agents. Okay, so especially in the vitamin tablets and also in the filling quarter tablets, the orders may be present. And also not only that, the order also indicates the stability. Okay, so for example, aspirin tablets will produce a smell of acetic acid. So it will indicate that the aspirin tablet has some stability problems like that. Then taste is also another important factor for consumer acceptance, especially the taste that agents are usually added in the chewable tablets. Then coming to thickness, so thickness of the tablets may or may not combine with weight variation. That means thickness can vary with no change in the weight, even though the tablet is having same weight. For example, paracetamol tablet, the weight of the tablet, if the dose is 500 mg, the weight will be 550 each tablet weight. But even though the weight of the 10 tablets, for example, if you are randomly selecting 10 tablets, and if while checking the weight, the 10 tablets is how the same weight. For example, 530 mg is the weight of 10 tablets. But if you're checking the thickness will be varying. So what is the reason for it? It's mainly due to the three reasons. First one, the density of the granules. While we are punching the tablet, we are taking the granules. So if the there is differences between the density of the granulation, thickness can vary, pressure applied at the time of punching the tablets, and speed of the tablet compression machine. So any difference occurs in these three factors. It may affect the thickness, but it may or there is no necessary that it will affect the weight variation. And the tablet thickness is important in reproducing tablets identical in appearance. And not only that, if 10 tablets we are taking, if it has 10 thickness, then the consumers cannot accept that type of tablets. Not only that, while packing of the tablets are usually packed in strips or blister packages. So if the 10 tablets have different thickness means we cannot pack the tablet. Okay, packing difficulties will occur. Okay, and while we are checking the thickness, a plus or minus 5% variations will be given, and the thickness is usually determined with the help of these three equipments: micrometers, vernier calipers, screw gauges. So in micrometer, this is the first picture. So here you can see two angles. The tablet is placed between the two angles, and we are rotating the screw. And while rotating the screw, here you can see a scale. And in this scale, you can measure with the help of the scale, you can measure the thickness. Second one is vernier caliper. Here also, you can see two jaws. The tablet is put between the two jaws of the vernier calipers, and the tablet thickness is measured. As in vernier caliper, the measurement is in centimeter, and in micrometer, it is in millimeters. Okay, so that's all about thickness. Next is hardness. So hardness means it is the force or length, load required to crush the tablet when placed on its edges. So what is the for what purpose we are determining the hardness? To determine the need for pressure adjustments on tablet machine. So while we are discussing about tablet punching machine, we said that before operating the machine, this pressure should be adjusted. Okay, so when the pressure is high means it may affect the hardness. And at the time of manufacturing, packaging, and also transportation time, if the tablet is not having a acceptable or standard thickness, it may affect, it will lead to cracking or breaking of tablet. Then thirdly, consumer acceptance. And not only that, hardness can affect the disintegration. That means if the tablet is too hard, it's already clear that it may take more time to disintegrate. And if the tablet is too soft, it cannot withstand the different subsequent process at the time of packaging, transportation, coating. At that time, the tablet will break. Okay, so if the tablet hardness is too high, it will affect the disintegration. And if the tablet disintegration, if the tablet is too soft, it will affect the packaging and some other process. Okay. So coming to the factors that can affect the hardness. First of all, at the time of compression of tablet, the force, the pressure that we are adjusting in the tablet punching machine, then amount of binders. Okay, at the time of wet granulation, if you are adding more binders means it will create more hardened tablet. Okay, more hardened tablet. And also based upon a selection of the methods. That means wet granulation method will provide more hardness, whereas slugging method gives the best hardness. And coming to the limits, oral tablets usually have a hardness should be in the range of 4 to 10, or we can say 3 to 6 also, 10 kg per centimeter square. And chewable tablets, 3 kg per centimeter square. Sustained release tablets, it may have up to 10 to 20 kilogram per centimeter square. And the equipments used for this purposes includes Monsanto, Pfizer, Smallcorp, and Ervica. Okay. So out of these four requirements, Monsanto and Pfizer are commonly used to determine the hardness of tablets. Okay, so this is the Monsanto tester. In the lab also we are having this tester. In this tester you can see one screw is there, then one scale is there. Then in this position you can see a moving jaw and a fixed jaw. We are usually placing the tablet, okay, vertically between this edge, and after placing the tablet here we are rotating the screw, and after rotating to some extent the tablet will break, and the force, so here you can see the force, how much force we have applied to break the tablet. Okay, so that is actually the hardness. So then from the scale you can note down the hardness of that tablet. Okay, and this is Pfizer hardness tester. Here also it's just like a hammer only. Sorry, hammer not, it's like a player that we are using. Yeah, the tablet we are placing here, and we are just pressing, and while pressing the tablet will break, and how much force that we have applied will be read from the force reading gauge. Okay, and so already we said that the official standard is for 5 to 8 kilogram per centimeter square, and for sustained release it is 8 to 12 kilogram per centimeter square. And next is friability. So friability means it is a tendency of the tablet to undergo breaking, or it is a tendency of a tablet to powder, chip, or fragment. It will also affect the appearance, consumer acceptance, and also it may lead to weight variation and uniformity problems. So for this friability, again, it is the equipment that we are used is a Roche fibrillator. Okay, it is a cylindrical again and an apparatus. The tablets are being placed here, and while operating this equipment, the tablets will be rotating, and if the tablets at the time of rotation, it will be falling from a height of 6-inch height. Okay, so the tablets we are placing here while rotating, this will come down. So the height that tablets falling down is a 6-inch. So, and the rotation we are 100 revolutions, 4 minutes we are taking, and after 4 minutes we will taken out the tablets, and how much then will physically examine whether any chipping or fragmentation occurs on the tablet, and again we are checking the weight. Okay, so the procedure is like that. 20 weight tablets are weighed together at the first, and we are putting this in the fibrillator, and the revolutions is 25 rpm for 4 minutes, and after the 4 minutes, we are taking out the 20 tablets. Then we are finding the weight again. Then we are using this calculation. That is, viability is equal to 100 into 1 minus W by W0. W0 is the weight of the tablet before viability. W is the weight after viability. And the limit that we are saying is that it should be less than or equal to 1%. So the maximum friability should be up to 1%. More than that means it is not acceptable. Okay. And the chewable tablets and effervescent tablets are highly friable. Okay. So that's all about today's topic. Thank you.